So the overview today is to talk about the air handling units, the typical definitions of and types. We will touch on obviously why do we need AHUs, the basic components of an AHU and fresh air, and we'll talk about obviously selection software that basically available. Each manufacturer has different ones, so we'll touch on the ones that this company use and others use. So what is an air handling unit? Simply, I know it as a box that delivers air, but let's give it more definition. Again, Google is best sometimes. It's used to regulate and circulate air as part of a heating, ventilation, and air conditioning system. Types of AHUs. Simply, an AHU delivers, obviously, as I said, and regulates air. But when we say it regulates air, that means it's a variable, and so that there must be a constant one. So there's a constant volume AHU, and there's a variable units. And simply how it works, I have a simple diagram you can see from here, gentlemen and ladies, that the air is circulated through the duct, the grills and diffusers, and it goes through the duct and goes back to the AHU. There's obviously a certain amount of fresh air that comes in from outside that goes into the building. The whole purpose of this is to remove heat mainly, so it conserves comfort in occupation areas, whether it's transient areas or there's a lot of movements. So types, we talked about the AHU, which is called the constant unit. There's also the fresh air handling unit. Is used for cooling ambient air. There's a medium of large capacities, provision for exhaust air, and also the provision for heat recovery option. So if I go back to the slide I had here there's no a wheel that's used to do the fresh air, but there's just basically a recirculating system, where this one has the option to have a wheel in between. So what do we need an AHU? Simply is conditions it's required to give us a comfort as a human occupation, stipulated by many guidance, whether it's BISRIA, whether it's ASHRAE 62.1, the dry bulb temperature, which is basically they've done a lot of survey and they looked at what kind of temperature that's most comfortable to us, and we could say that it's 23 plus or minus 2 degrees Celsius. Now, I may be comfortable at 23. Some people may not see it as a comfortable temperature, but again, it's most of the survey they looked at that's the kind of temperature they could fall in. Humidity less than 60% is comfortable considered. The CO2 level below 1,000 ppm, again, considered a comfortable kind of a zone. It has to be free from dust, smoke, matters, particulate matters, free from obviously bacteria and viruses, and non-odorous. These are the criteria. But moving it into the ASHRAE 62.1, we could see that the issues faced due to non-ideal air conditioning starts from carbon monoxide, formaldehyde gases, nitrogen dioxide, and other respiratory issues that could be giving us different symptoms. So carbon monoxide gives us headaches, dizziness, and where the others gives us respiratory issues, irritation to the eyes and nose, and so on and so forth. So let's go into the basic components of fresh air handling units. So it starts from the inlet side. So you have a pre-filter and a back filter that goes into the bottom, as you can see from here. There's also a cooling coil wrapped around with the heat pipes. Obviously, you have the fan. That's the supply. It goes into the supply. You have in between those elements, you would have a heat recovery wheel, and we'll talk about it later in details. There's a pre-filter that goes into there from the exhaust that's coming from the building, and then you have a return air fan at the top. One important element of the whole thing is to have a sand trap louvers. I mean, certain clients and customers require sand trap louver, especially in this industry that we live in this region. There's a lot of sand, obviously, and it requires some sort of protection. So beside the pre-filters that we have, the Centra Pluva is a product that really helps out basically the AHUs and the occupants. Filters, without saying any further about filters, obviously, I'm sure the expert will talk about it in a bit. We have a couple of colleagues that talk about it in details. But the air must be filtered before it gets dehumidified and cooled. So we do need filters into this system. There are different types, obviously. There's a chorus filters panel or pre-filters, filter types, back filters. We have the HEPA filters. We have the carbon filters as well. That could go into the AHU. So we talk about the filtering sections, and the chorus filters, obviously, the filters dry dust, used as a pre-filter to high efficiency, synthetic in terms of materials, media placed in zigzag, sometimes shaped. There's also fine filters for those requirements that needs this to be in place. Heat recovery wheel has many names. There's a thermal wheel. They call it rotary heat exchanger. So there's many acronyms that can be used. It's basically a heat recovery wheel. Is a slowly rotated within the AHU. It's made of aluminium, mostly made of aluminium, and basically it works at the two temperatures that go in. So you have the fresh air going into the system, the supply air from outside is 46 degrees Celsius usually. And the return air comes from the building, obviously, at 25 degrees Celsius. It goes up roughly, we're talking about 20 RPM. Usually that's how it rotates. And the whole purpose of this is that the return temperature will cool down the elements on the top, and basically when it reaches to the bottom of that section, then it cools down the temperature. This wheel can save energy in the region of about 40%, sorry, of the energy consumption of the AHU. We've given you two examples here in Dubai. As you can see from here, a dry bulb of 46, and then we have the outdoor air conditions, obviously, and then you've got the density of that. I don't want to go too many details into this, but the table shows you how much capacity that this wheel can save us from energy perspective. Again, further details. We think that we can basically see a saving of 60% by using this system. And then obviously that's debatable from different manufacturers, but we calculated, we assumed that there's about 60% savings. A cooling coil is a must, obviously. Obviously, a cooling coil is the primary component of an air handling unit that is used for cooling and dehumidifying air, which can be either fresh or recirculated. It's often referred as the heart of the AHU. A typical calculation here, and guys, I won't bore you. I think we have the penalty of 10 minutes to deliver this. But basically, it's a simple calculation that can show us exactly what we're looking at in a cooling coil and how we can achieve the coolant and the dryness in the air. Cooling coil sections, there's a smaller coil face area, low in cost, is used for smaller AHU footprint, and you got the larger ones, which gives you lower air pressure drops and obviously low water pressure drop. Fan section, often referred as the blower, mainly in the US, is used to maintain the airflow rate and pressure through the AHU and duct system. Classification based on flow forward, obviously curved, the backward, and the airfoil. Classification, we've got the centrifugal fan and the plenum fan. We can see here the centrifugal on the top, double width, we call it WDI, and the motor drive fan by pulley, easier to make, obviously, and it can be used with the VFD as an option. Centrifugal plenum fan also on the bottom, you can see single width, obviously motor direct mounted to a fan. Overall fan section is smaller. VFD is mandatory, obviously, in certain criteria. Again, we see more of the EC fans. This is obviously becoming more popular with most customers and clients. It's brushless, the impeller direct coupled to the motor. Vibration isolators are used, or not used, sorry. Fan wall or the fan array, we can see here from on the other side as well. The selection software for the AHU design obviously varies from one manufacturer to another, but it has to be certified by Eurovent. The design obviously encapsulates all the types of AHUs that can be used. It calculates the load, includes the technical selection of all components such as the heat recovery, the coils, the fans, the filters, and also is flexible design to suit the customer requirements. I think I've come to the conclusion, so we'll take the questions later on. Thank you for your time, guys.
Thank you, Saad, for giving this overview. A question regarding belt-driven fans. How strong is this still in the market? Because the disadvantages of belt-driven fans regarding maintenance and also the troubles with abrasions from the belts to the indoor air is not really an advantage for that. Is it still a strong market segment?
It still is. I mean, obviously we've had this slowdown of the closures, but it absolutely is still a strong demand. Yes.
Well, here the message should be then in the future to definitely retrofit and upgrade to other fan drives, right?
Absolutely, it's the retrofit business obviously is growing in the Middle East, as we know, and we see a peak, so it's definitely recommended, and we will continue to see a growth in there.